Hello everyone, this is a preview video of what I have done so far with my application SolarDroid. So first let me give you a little background information on what a solar pathfinder is. Let me show you a picture right here. Okay, so when engineers or a renewable energy company need to install solar panels in a given spot, they need to measure how much sunlight the place receives. In a general way, in a general explanation, it consists of a spherical glass that has a diagram beneath it. Here I have the kind of diagram that you see under it. The spherical shape lets you see the reflection of buildings and trees that are around you. When you look at the diagram beneath the glass, you can see some of these objects blocking the diagram. As in this picture, you can see the trees and this building right here. So this indicates that these objects will block the sun on the given time shown at the diagram. You can look at this as a Cartesian plane that has been bent depending on your latitude. This diagram that I have here is barely bent since I live in Puerto Rico and it's fairly close to the equator compared to the United States. Each horizontal line is a month of the year and the vertical lines are the hours of the day. The numbers that you can see here, these numbers right here, they indicate the light intensity. As you can notice, the closer you get to 12 p.m., the bigger the number get, because that's the hour that the sun gets that you get more direct sunlight. So ideally, if nothing is blocking, you will get 100% sunlight throughout the year. But if, for example, you get, let's see, a tree blocking only this area, that would mean that you will receive, let's see, 3 and you have 6, so you will receive, let's say, 9 points less on that 1200 total. So typically the person using this will either draw on the diagram with a white pencil and then add all the numbers that haven't been blocked. They just put the numbers in a spreadsheet and the computer would just do that. They also take a picture like the ones I have here and fill the same tables just by careful examination. This isn't hard. This isn't really a hard task. It just takes time. Not usually they have to make these measurements in 5, 6, or 10 different spots in the same place. So they have to fill many tables, and just entering the data is time consuming, and also they need to go home to get the results. So what I intend is to eliminate that data entering part, and I also intend to give the user the results on the spot. Like right there, he could just take the 5 pictures and know if the place is worth installing solar panels. I'm going to show you a very raw version of the application. It has some buttons and some tools that the user won't actually see. For example, this camera, this window right here, it isn't even a close version of what I'm going to do right now. Typical scenario of how the program is going to run. First, the person would take a picture. Right now I don't have a solar pathfinder with me, so I'm just putting a picture that I saved in the tablet. So here it is. Here we have a picture. Here I have a frame. This circles and this line, that they are used to align the picture. I have already, this is one of the parts that I need to change. I have already thought of some very simpler ways to do this, so the faster ways and more natural, more accurate. It still beats making Excel tables. So here I have something pretty close. Okay, so once we have this ready, we can start drawing the things that are blocking the sun. So let's begin here. I'm not really picky with the trees since they will grow, they will change throughout the year. Here I have this building. So now we can select the part that isn't blocked by the trees and the buildings. Here, here runs an algorithm similar to the bucket fill that you can find on Microsoft Paint. So this application is basically just a drawing application. The picture is just behind, like it's just back there. It's not doing, actually it's not doing anything right now. So once the person selects this area, it opens a file that has all the coordinates of the numbers that are in the diagram right here. So it checks for each coordinate to see if it is blue. If it is blue, then each coordinate is saved to an array. Also, that file besides having the coordinate, it has the value of each one. And what I mean is that it also has the numbers that are written here. Remember that, for example, each month should add up to 100. So if this month is blocked here, so you would get a 99. Okay, so once you finish this part, and you can see that everything is going fine. This window right here isn't really that fancy. I am here just testing to see if I'm getting the right coordinates. As you can see, that it's a lot of coordinates, so it's a lot of data entering that you are saving to do. They actually just they have like a default table, and they delete the numbers that are being blocked, and still you have to make a unique table for each case. But right here you can just take this picture, draw, select the sunny area, and you get right here the total. Here you have 788 from the 1200 total, and that gives us 66%. This is a bad percentage. This is like a place that you wouldn't want to install a solar panel. It's not actually receiving too much sunlight. 75% is the least that you should consider to install a solar panel. So I still need to add some features to it, since the persons need to make these measurements in more than one place. I need to be able, the user needs to be able to like make a profile of a client and just add as many measuring points as he needs. Also, the aligning part, I have already thought of some other methods to do it. I need to make it more natural. It's still, as you can see, I am already used to it, and I could do it fairly fast. I already have the results right here in like 5 minutes, maybe even less. So it's still a lot better than Excel, but there's a lot of things that I can still do with it. So I hope you like the idea. As soon as I can, I am going to upload another video with the program, this app working on an actual field with an actual solar pathfinder, so that you can see it in action. So stay tuned and see you later.